Hi, Cheryl.
Hi.
How are
you doing? I'm doing okay, thanks.
Hi, Laren.
Hi.
Hi. I just sent you a document we can talk about it after, but for the inference and the take action thing.
Okay.
Okay.
I forgot how to do a lot of things.
I know.
Yeah, this was a good review, really.
Yeah.
But I'm just worried about all this. I'm worried about all the stuff that wasn't covered.
Oh yeah.
Because going through it, there was a lot that. Yeah.
I still have a hard time when they give us the last 5 questions or so when they're like, "Okay," they give us like a scenario.
Yeah.
I'm still mad at that. I'm just like,
and that's I had a problem with was when they gave it, they said, "What's the alternative, a hypothesis?" I kept doing the wrong ones. Like, I mean, I got the gist of it, but they were like the wrong.
Yeah.
Oh.
Like I thought they were something else, so I was like, "Oh dear." I only got like 80% when I did.
Oh, mine was way worse than that. I was like, "Oh boy."
I'm like, "Oh well, maybe they know what they're doing." All right, should we just open it up and go through them?
Sure.
Sure.
All right. Okay. So number 2, the number of people in a random selected classroom on campus.
Yep.
Yep, that's the only one.
And number 3, the observational study, because the students had no control over the price of the individual cereal.
Yep.
And number 4, not possible to determine without the full data set.
Right.
Okay, number 5 I got wrong, so I
did too.
I put the 99.7.
Me too.
The
0.3? 0.3? Like, I don't know.
So
it's 3.
Well, it's because
it's less than 50.
Approximately what percentage of students will complete the exam in under 50 minutes?
So
it's I remember last time I did it, I think not this test, but like previously.
Yeah.
And I was trying to find it in my notes and stuff, but I couldn't. because I just used the 50 thinking, okay, 50 is 2 standard deviations and I use 95, and that's wrong. It's got to be like right under.
So it's everything to
it
the
says
left.
Right over, right
To the left.
But I don't know how to determine.
I don't either. And then I was like, was there something that was like, there was a, like I remember something about 5% and then dividing that because it's only half, so 2.5. Like I don't know why that's in my head, but I can't find it anywhere. So
Yeah,
I think
so I don't
it says to use this rule, so I guess we should review the rule. 1% falls within 68. 2% falls within 95.
Trying to figure out what lessons.
It's got to be just right after. It's got to be right after 95%.
Yeah.
So, Laren, on this one, you put 99.7?
No, I put 2.3% because I was figuring out, so 50 minutes is 2 deviations away from 70. And so I put, in the normal probability applet, I put 2 for the standard deviations, and then I just filled in the far left, and it gave me.
Okay, I'm not sure if we're using. I don't think we.
And I changed it to 3%.
This is before we learned the probability applet, so I don't think we put that.
And I was like, I don't know how to do this one, so.
Just guessing. Yeah.
Well,
I do not know. So we come back to that one or find it.
95.1 because.
No, I think it's anything. We're not wanting to know. It's wanting to know less than 50 minutes. So it's going to be like a pretty low percentage, right?
Yeah. And I think it'll be higher because that okay, the mean for taking the test is 70 minutes.
Yeah.
So 1 standard deviation is 60 minutes.
Mm-hmm.
2 standard deviations is 50.
Yeah.
So 99.7 of the people are going to get it done within 3 standard deviations.
Yeah, but they're wanting to know under 50 minutes, not like
to the left of, so between third deviation to the very end of that chart. That's what they want to know.
Yeah.
The lowest end, which is just, it's got to be something low. But
do we need to do? Is this the one where? Maybe not. Is this where we do 50 subtract 70 divided by 10?
And what is 10? Oh, the standard deviation?
Yeah. So.
Or do we say 49 instead of 50? It has to be 49. Because it says under 50 minutes. Or not. I don't know.
I don't know, because I just figured. I don't know, because.
Okay.
Because I thought I did it.
Okay, here's something I found. Wait a minute. Okay. So here's a question on something we did, a test review. It says, the time to complete a standardized test, it's the same quiz, I think. The mean was 70 and the standard deviation is 10.
Mm-hmm.
The probability, what percentage of, oh, this one is what probability, no, approximately what percentage of students will complete the exam in less than 1 hour, and the percentage was 16. And this one's asking for less than 50.
Oh.
So do you have your equation that you used, Wendy?
No.
Oh, okay.
I'm like,
okay, so
yeah, so it was 60, 70,
okay,
over
divided by
divided by 10. So if we do 50 divided by 10, but that only that's not right.
So I think what it was doing, you have to enter it into the applet. So that's the thing. So when you do that, in that problem that you just read, Wendy, you wanted less than an hour, right? So you did 60 minus 70 divided by 10, and it gave you -1. And then you enter it into the applet in the z-score, and you shade to the left, which they wanted less than, and the area at the top was 0.158. So then you would change that into 16%. So on this one, we would do 50, right? Because we want to know it's less than 50, so it would be 50 minus 70.
Okay.
Divided by 10, right? Because that's our deviation.
Yeah.
Which is -2, so we need to enter 2 into our z-score on the applet and shade the far left. And it's 0.0228.
It's not a negative number? Or
no.
Is it negative?
No. I mean, your z-score was -2, but
yeah,
z-score is -2.
Yeah, so we would shade the far left portion.
Okay, and 0.28. So it'd be 0.23.
But are we?
It just says to do it 1 decimal point.
So I'm wondering.
We change it to a percent, I think.
See, and that's what I think I did last time. I said 2.3%, and it said I got it wrong.
Oh.
So I don't know.
Oh.
In less than 50 minutes. Unless I'm not supposed to round, but don't we always round?
I think so. So 2.3 is not right. Is that what you said?
Yeah,
apparently it's not right.
Okay.
So if it was 16%, it shouldn't be.
Because it wants us to do 1 decimal place, right?
Yeah.
Yeah, it should be 2.3.
Yeah.
Okay, well, it says in the problem, it says use that 68, 95, 90, 97 rule. So in what you just did, how did you use that rule? How did you apply it?
The fact that it's the fact that it's 2 deviations away. Is it 5% then? Because it's 2.
It says using.
But then again, that would be counting those who were less than 50 and more than 90.
That's right.
So then it would be 2.5 if we divided that by 2, right?
Yeah.
So should we do 2.5?
That I kind of remember something about that, so that's why I kept kind of going back to that. But.
Two deviation.
I don't know. That's my only guess, is that it's 5%, but that would include the top and the bottom, and then we would have to divide it by 2, so then we would just have the bottom.
Really familiar to me. That's what I kept.
That sounded familiar. Okay.
So well, I guess I don't know what this is. We can come back to that one if we.
Okay.
All right. So number 6.
Okay. Where are we at? 6. 146.8.
Yep.
And then it's skewed right.
Yep.
And this one, number 8, I spent a lot of time on it because it's different in the exam or in the review part, because it says find the mean of, or find what it was with 8544.
Right.
Instead of the 8. Now here in the test it says 8550. So I was trying to figure how could your sample mean be the same as your or your sample, whatever. So
how do we do this?
2.236. Okay, so you take the 8500 minus the 8544 and divide it by the standard deviation of 12 gallons divided by the square root of 20.
Okay. I think I switched the 2 numbers on top when I did it. Okay.
Yeah.
So what did you get then?
I got 2.236. And
then, so for question 9,
I got 9.
Sorry, what did you say, Wendy?
I got number 9 wrong.
So for this,
so you take the 8540 and minus the 8544 divided by 12 divided by square root of 50, because they changed the sample size.
Yeah.
So I got 0.991.
I don't know what I did wrong on that one.
Did you go the 8540 minus 8544?
I don't know. I'm looking for my sheet. When I was looking for that other answer, I lost my other.
Oh no.
It's in my. You should see my table right now. It's really ugly.
Oh yeah, my whole kitchen table has every lesson out. So
I had it.
It's a good review.
Stuck it with here. Maybe this is it. Oh, here it is. What did I have? What number was that? 9?
9.
Oh, I had for some reason I put 0.00 something, but I did go back and look at it and figure out the right answer.
So on question 9, what did we end up getting?
0.991. I did not round. When I put 12 divided by the square root of 50, I got 0.697056275. And I didn't round that when I divided. I have -4 because 8544 or 8540 minus 8544, you get a -4.
Yeah.
And then I divided it by that long number there and got a z-score of 2.357.
Yeah. 2, 3.
Negative, yeah.
Right. -2. Yeah, I went back and did it right. I don't know what I did the first time. Oh, number 10. Did you get the probability of an type 1 error?
Yes.
Okay. And then for number 11, well, there are 2 answers.
Yep.
We're 95% confident in the approximately 95 of all 95 intervals.
Yep.
Okay. Well, yes, the distribution of sample means is normal because the data are normal.
Yep.
All right. Number 13, I got wrong.
Okay. I'm trying to remember what I did on this.
Okay, rates of return. What test did you use?
Yeah.
Or does it ask that?
Let me see if I still have it in here. I think I used, what did I use?
This is the one, should be the one test, one t-test or something like that, right?
Yeah, I was wanting to find the differences, but I guess that wasn't the right one.
I did that
one sample t-test.
Yeah. Mm-hmm.
But what I got for the p-value was wrong.
Did you change your type of test?
I don't know. I had less than. Was it supposed to be less than?
Yeah.
Yeah.
Let's see.
I had 0.128, but I don't know.
Okay, well I got 0.19. 0.019.
Yeah, 0.019. I'm just trying to remember how I got that.
0.019.
Well, shows the p-value. It's given to you in a one sample t-test.
Yeah.
So what do you have for your null in that little blue thing?
0.95.
Yeah.
And less than.
And the null hypothesis is it's set at 0?
Less than.
Yeah.
Oh.
Why is mine wrong? So what is your...
So your null hypothesis is supposed to be 0.95 because it says the population mean is 0.95, and you're trying to see if this company is significantly less than that population mean.
That was what was wrong.
Yeah.
I just put that in and it's right now. Okay. Yeah, I was like, I don't know what I'm doing wrong. Okay. 14, dependent sampling. He needs to select couples.
Yeah.
Mm-hmm.
Okay, 0.096 for the p-value. So no, because the p-value was greater than the level of significance.
Yep.
The distribution of mean differences is normal because the data has been determined to be made.
Yeah.
And here's one I got wrong.
I got 18 wrong too, and I don't know why.
You got to do the difference. It's the one. It's the null hypothesis is the mean of differences is equal to 0, and then the alternative is the mean of differences is equal to not equal to 0.
So it's I put the mean 1 equals mean 2.
Yeah, I did that one because I saw you wanted to see if the two appraisers are different, and so I was like, oh.
Yeah, that's
what I thought. Okay.
They really want us to know that we know that 95% of all 95.
Yeah. And watch, that will be the only one we know, and it won't be on the test. Okay, so 20, I got 50.
Yeah.
Yeah.
I remember that from the last time.
Yeah. I always get stuck on the probability ones for some reason.
I didn't do both I only did the first part of the problem.
Yeah.
You know, not the second one.
Uh-huh.
That's why it was throwing me off on some of these other ones where.
Oh, yeah.
Yeah.
Okay, so 21.
That is no.
Yeah, no. And it's the times 40 times 0.233.
Yeah.
Okay, 22. 51% units in the sample have the male chromosome.
Yep.
I remembered we had a question like that, so I went back.
Yeah.
Okay, this one, number 23, I got wrong.
Me too.
Me too.
Oh boy, okay.
I couldn't remember this, and I kept on trying to go over it and look. Okay, lesson 16, I was finding stuff, but I wasn't able to work it all the way through.
Okay.
Yeah.
There's nice.
Okay. So this one is, I'm not sure if they're giving us too much information here with the, why is it say 40, 45% of the adults over 65. And then really all they're giving us is the 320 over 750. So I divided that to get that 0.426. But then I wasn't sure what to do with it after that.
Oh, that's what I don't know if that is the answer.
It wants to know the probability that there's fewer than. So sounds to me like we would need to. So you got 0.426 when you did that, right, Cheryl?
Yeah.
Why do I
just divide 320 by 750?
So less than that.
Well, I had 427.
I mean, but that's not the z-score. That's just the
yeah,
sample.
The percentage out of.
Yeah. But I'm not sure how to find a z-score because with just that information that they gave us, I didn't think that there was enough. There's something missing that I'm not seeing.
Yeah.
Okay, hold on. So we have an N. So okay, hold on. Let me see. So I think what we need to do is hold on. So our sample size is 750. He wants fewer than 320. So it was 0.426, right?
Yes.
Round up, it's 0.427. Because on the calculator, it's 0.4266666.
Oh, yeah. 4. Okay.
So 0.427 times 1, subtract that, divided by. Okay, so I think what we need to do is do 0.427 times 1, subtract 0.427, divide by 750. Does that sound? Because we're trying to find a standard deviation, and then we would enter that standard deviation into the applet, and then we would shade the left-hand side, right? Or is that not right? I don't know.
And so timesing that by, I'm not sure how you times it by what number?
So.
Oh, so what I did was 320 divided by 750, and that's where we got our 0.427. But the standard deviation equation for the proportion is 0.427 times 1, subtract 0.427, and then divide by 750. That's our sample size. And we get 0.0003. Maybe that's not going to matter. I mean, my group, unless you want to be on camera.
So what did you get?
0.0003. And then I entered that into the applet, and it's 0.50 as the area. I don't know.
Yeah. Yeah, this problem sounds familiar.
I don't know.
Yeah. A lot of these problems are. I wonder if they just took them from our quizzes and our homework stuff and put them on here. So this is a proportion, right? Like we're working with like the P and P hat stuff.
Yeah.
Okay.
Yeah, I got out lesson 16 because on homework 16 has a problem sort of like that, saying, well, they were tossing a coin 4,040 times, and it says, so what's the probability that the p hat will be less than, and then it says a percent, and that's kind of the same thing of what we're trying to find here. Yes, but I don't see how they got the z-score. How did we get it?
So the formula is P equals P hat minus P over the square root of P times 1 minus P over N. That might be our formula we're supposed to be using.
Oh, yeah.
Ah, okay. I got it. The standard deviation of the p hat.
Okay.
Yeah. Okay.
So what's our p hat would be our 0.427, right?
Right.
But then what's our p? Is that 45%? Or what? I'm not. Because that's the population proportion. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. So, right, isn't that so? Our sample proportion is the 0.427, and then our population proportion is 40.45, right?
I think so.
Okay.
Okay, so 45 times 1 minus the. And then divided by 750. Okay.
The square root.
Right, square root. Okay. 1 minus 5. Did you get 0.018?
1806178. So 0.018066178 as when you did the square root of the bottom part.
It's square root of the whole thing.
Just the bottom.
Just the bottom.
Oh.
And
Okay,
then don't we... Oh,
looking
sorry,
at
go
the
ahead.
wrong. I was looking at the wrong formula then. Okay.
Oh, shoot. So your final answer, did you get 1.266?
I got negative 1.273 because our P on the top, it should be 0.427 minus 0.45. So it should be a negative number, shouldn't it?
Oh, yeah, I did backwards. I did. So what did you get?
For everything on that Z answer, I got negative 1.2734.
I got negative 1.266.
I might have, here, I'll I don't know, I'll redo it. I might have done it wrong.
Okay, can you tell me the formula one more time, please? Because I'm doing the wrong formula.
So P hat minus P divided by the square root of P times 1 minus P over N.
Wow.
Wendy, what did you get for the bottom part of that equation?
0.0181659.021. Is that not right?
I got the 0.018, and then I got something different after those numbers.
Okay.
Are you doing 0.427 or are you doing 0.4266666 whatever?
Just 7. Well, on that, is it our P? Our P is 0.45, right?
Well, that's what I'm doing wrong. I have the wrong numbers in there.
Okay.
Okay, now that's cool. So you got negative 1.266?
Yes.
And then you got the area. Are we doing less than, right? So it'd be 0.123.
I got
The area on top.
1028.
Yeah. And then when we, sorry, yeah, you're right. And then when we round it,
Oh, yeah.
103.
Yeah. Cheryl, are you getting that? Oh, Cheryl's gone.
Oh, no.
Let me re-invite. I didn't even know she was busy.
Me either.
Oh, there's Cheryl.
I had my computer plugged in, but it came loose, so it died.
Okay. I was like, oh, I go, Cheryl,
Yeah.
are you getting that? And then I looked up and it's like, oh, she's not there.
Sorry.
Okay. Where did you leave off? Did you get that the answer or no? Not yet.
Not yet. I'm still
Okay.
working on this formula. So.
Okay.
Can't be right. Is the sample size square rooted in this one or not?
No.
No.
The whole big thing for you, but not by itself.
Okay. I'm not getting it. We can move on, and I'll come back to it.
Okay. I'll just, so we got for the Z-score, we got negative 1.266.
Mm-hmm.
Okay.
And then we put that into the probability app, dated the left side. And it came up 0.1028. And then when you round it, 0.103.
Okay.
Okay. And then number 24 is 0.182.
Yep.
4. Yep, got that. And then any N will do?
Yep.
Which one?
Any N.
Oh, I
It's
got this one wrong. So what?
It tells you in here that,
Oh,
okay, it is known that the distribution of fertility levels of Cocker Spaniels is normal. So if we know it's normal, then any sample size will do.
okay.
Yeah.
That was a trick question.
Yeah.
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 And I fell for it. All right. 26, no, because the sample size of women is too small.
Yeah. So on this one, it would be no, because at least in one case,
Oh, wait.
it's less than 10.
Is it the same question?
Yeah, it's the same question. That's just
They reworded it.
all the other answers are the same, but that answers
So it's
somehow they
at least one case.
uh-huh.
Okay.
Gotcha.
Yeah, that was
Right.
a little bit worded differently in the review.
Yeah.
Okay, number 27. I got this one wrong, but is it supposed to be the P1?
The
No.
differences are not equal to 0.
Yeah.
I get these so confused.
Yeah, it's like you have to really pay attention to what they're wanting you to do. It says the study wanted to test whether there was a difference between before and after scores. So there was the mean difference, so the UD.
Okay. See, and I saw, oh, there's two things, so I did the U1 is not equal to U2,
Yeah.
but it's the difference. Okay. 28, I got wrong too.
So his actual weight loss was 5.5 pounds higher than his predicted weight loss. Because
and why? How do we know that?
it's
because the definition of the residual. So the residual is the difference between the observed and the predicted.
Yeah. So, and since it's a positive pounds, it's not a negative pounds.
Okay.
His actual was higher than his predicted. If it was, I'm assuming if it was negative pounds, the residual was negative, he didn't lose as much as he was supposed to.
Right. Yeah. Okay.
And 29 is as proceeded goes up by 1. Weight loss in 3 months increases by 5.
Yes.
Mm-hmm.
And then, okay. So the only ones that we can check for is the only ones that we can check on here. So the residuals are normally distributed.
Yeah.
The linear relationship.
Yep.
Okay.
And then the variance.
The variance of the error.
Gotcha.
Yep.
Okay. Okay, did you get an R score of 0.78?
Yeah.
Yep.
The linear was fairly strong, positive.
So when I did that scatter plot, there was some like outlier, like it wasn't, they weren't all grouped together. Did you guys have that same thing, or was my scatter plot wrong?
It's just that, let me pull it up.
Yeah.
No,
Don't you use this?
Outliers, but it didn't form like a or whatever it's supposed to. Let me see. Where are we?
Do you use the one that they've already made, or do you have to do? Did you look at the scatter plot that was already done, or did you do different data?
No,
okay.
Did I have to do the different data one?
I'm not sure. I was just looking at the one that was already done in here.
There's a lot at the bottom. We kind of go off.
Yeah. Yeah, there's a lot there, but it
kind of follows the line.
It looks to me.
Okay, yeah. I just there was like a couple outlier dots, and I was like, okay, So I put non-linear, but then I realized it was wrong.
Well, you can look at the R, and if the R is
Oh yeah, I forgot about that.
close to 1, then it's positive.
It is.
Okay, yeah. Okay.
Positive non-linear. Whoa. Okay.
Y-intercept 5.64.
Yep.
115.
Yeah, 150. The whole time I was doing this, I kept thinking, did I put the right numbers in the right box?
Yeah.
Or I'm going to get all of these wrong.
Yeah, there's a lot riding on that one problem. Okay, let's see. 0.627.
Yep.
Yeah. So this one is 2441.0.
Yeah.
The lower 0.518.
Yep.
Yep. The margin of error is 0.109.
Oh, yeah.
I put 1.108 last time, and I got it correct.
Oh, I put 0.109 and got it right.
Me too.
Well, I'll do what you guys have. So.
Well, I think they said they kind of let a little room.
Oh, really?
For the, yeah.
Okay.
I did get this hypothesis right.
All right.
So it's the beta 1 equals 0, and then beta 1 doesn't equal 0, right?
Yeah.
Isn't that beta? Am I saying the right term for that B?
I think so.
Okay. I just want to make sure.
I know, it's like, I was talking to my sister, and she's like done. She just has her internship. So I was like, I'm so glad statistics is over. She's like, what do you have next semester? I'm like, epidemiology. She's like, you have to do statistics in that one. I was like,
I have that one next semester too, I think.
Yeah.
Oh.
Yeah.
I'm like, dang it.
It's not going to go away.
Yeah, I know. So our test statistic is 11.509.
Yeah.
And then our P value is. Oh, go ahead.
How did you get 11.509?
Did you look at the slopes test statistic?
Yeah, mine says 11.510. And that's what I put in, and I got it right the first time.
Mine says
really
11.509 too.
That's weird.
Yeah. Oh, I wonder. Did you leave the ones in that didn't have, like, if you had one ticket price, did you take those out or not?
No, I did not take them out.
That might be the difference.
Are you supposed to take them out?
I did, but
I did too, but I don't think it tells us. Oh, it says notice that some destination have flights that are not available. But if you got it right the first time, I don't know.
yeah.
Weird.
Okay.
And then our p-value is 0, pretty much, right?
Yeah.
Yeah.
So that means we reject the null. And then sufficient evidence.
Yeah.
Okay. These ones I don't know because I never get them right. I don't know.
Okay.
One sample t-test. I remember what he was, if there is no mention of a standard deviation, it's a t-test. If they do say that there's a deviation, then you would want a z-test. Okay. So the first one does not talk about any standard deviation.
So you're on 39?
43. Oh,
yeah.
39 in the review. Yeah, it's a one sample t.
See, I think the reason I thought it was a paired is because it talks about how they're doing a new prenatal program, and so I figured that they had to weigh them before and after they did the program, but whatever.
Well, I had independent. So. No, wait, 39?
Oh.
Yeah.
Yeah.
So one sample t-test.
One sample t.
I got that one wrong.
So what were you saying? If they don't mention a standard deviation, it's a t-test.
Yep.
Okay.
And then the standard, if they do mention it, then it's a
z-test.
Okay.
And so that's what the next one is, because they mention a standard deviation.
Ah, interesting. The next one is a t-test.
That one's the engineer one?
Yeah.
Okay. One sample Z. I think I guessed that one right. And I didn't guess.
I don't know. These questions, I have the hardest time with these.
Okay.
That's a test for one proportion.
Yeah.
I did get that one.
I got that one right, yeah.
Okay, the next one I have no idea. I don't know. I had paired, but it's not paired.
And I put the chi-squared, so it's not that one. So.
Is it independent?
It can't be independent because they're talking about, right? Aren't they?
Is it ANOVA?
Like, it could be ANOVA. He wants to, okay, categorizing each of the couples as communicative or non-communicative.
It has the word percentage in it, so that is
other things.
Percentage means something. Let me see.
Okay.
He said keywords, a percentage equals 1 or 2 proportions.
So this is a 2 proportion.
Yeah, because I had 1 and it was wrong, so it must be the
2 proportion.
Yeah, so 2 proportions. Okay.
And then linear.
Yeah, finally one I knew.
Whew.
All right.
So the proportions are when they use the word percentage?
Yeah. If they use the word percentage, what do you say?
Yeah.
Keywords, percentage or proportions. We know that it's a 1 or 2 proportion.
Was that in his last review thing?
Yeah.
Okay.
Why will my test not submit? Okay, we got 100%.
Woo!
So we did do that one right. 2.5.
Oh, yeah. Okay.
Okay, I sent you guys.
Can you tell me what lesson? Let me see. Because I'm
lesson 16 on the prep. It gives you
listen.
Equals value subtract mean divided by standard deviation.
Okay, 16 prep.
Here, I'll show you the equation.
Yeah.
Possibly.
Well, it's the.
Can you see it? Like
Yeah.
right here.
Is that for the Z-score?
Yeah.
Yeah. Because we're doing, this is a proportion Z-score, so it's a little different.
Okay. All right.
Do you still need it? Sorry.
No, thank you.
Okay. Yeah, and then when you get that Z-score, then you have to put it into the applet, and then we shaded to the left, Wendy?
Very left.
Yeah.
Because it was like less than 50 or whatever.
Okay.
Or, no, that was a different one. Less than something.
Okay.
Yeah, what was less than 45%?
So on that question, number 5, that we were working with those first standard, okay, it was 2.5. Okay, I'm just trying to write down notes on every question that I got wrong.
Yeah.
Or didn't know how to like work it or whatever, and then.
So we figured that was that 5%, and then we divided 5% by 2.
Okay. Then.
Yeah, that 0.595% for that test, that threw me off. So I didn't even put that in. So I got that one. Is he gonna do it or not?
I hope so.
I haven't gotten an email, but he usually doesn't do it. Like, he might send it out tomorrow or Saturday or something. Because doesn't our test open on Monday and close on Wednesday?
Is that it does?
I think so. I can look.
Oh, yuck.
Okay, I got one wrong. I must have done it
Which one?
It was question 22 about the geneticist takes a simple random sample of 140 gamete cells from the dogs and comes up with a p-hat of 0.512.
Yeah.
And is it?
It's on my test.
Okay, I put 51.2% of all gametes in the dog's testes have the male chromosome, but it's the sample, right?
Sample, because it's a proportion.
Okay. Yeah, okay.
Yeah.
At least, as long as I understand what I did wrong.
Yeah.
Yeah. Okay, yeah. So the exam opens on Monday. Or wait. It says it starts at Monday at 10 p.m. and then closes on Wednesday at 10 p.m.
That's dumb.
But I don't know why it would open at 10 p.m. on Monday.
Yeah.
Anyways, but yeah, so I'm assuming it opens Monday and
Closes Wednesday.
Yeah, it has to be done by Wednesday. That's I
Yeah.
remember. I have that on my calendar.
yeah, I'm like,
Take this one on Wednesday.
yeah. But yeah, so I was like looking at the stuff. So we don't have to meet next
Right.
week, and we don't have any homework. The prep is kind of like just.
So it's the project. Do we want to meet to get for the project?
Yeah. Do we need to the PowerPoint?
I get we can. It's up to you guys. I mean,
will you look at your email for that and see if I'm on the right track, what I need to add, because I don't, especially to take action, I did not know what I was doing.
Okay. Let's see.
And then also, when you state your null hypothesis and alternative, I couldn't find anywhere, but do we have to do the like the U1 equals U2 equals U3?
no, I think what you have as the null and alternative hypothesis is correct.
Okay.
Because this is
it
the ANOVA.
And words and numbers or whatever. And I was like, I don't know.
Yeah, I think it's
just this one.
Yeah, it's just that.
This one means difference. Data.
When they say one paragraphs, I don't know what else to put in there besides what I did.
Okay.
I think what you have is good. I mean, I don't know.
Few Q plots, just to put in there.
Yeah.
And then, I have the null hypothesis. I got to change that because I put it at the top.
Oh, yeah. Okay.
After, so I just need to erase that one at the top.
Okay.
And then the take action. So I got our. So I put that our alpha level was 0.05 because everything I read said that was the most.
That's the most common. That's what we would use. Yeah. I think that's. Yeah.
So yeah, I think it looks good because it all makes sense. I mean, if you.
So is that how you write? There is sufficient evidence to suggest that there is a difference in the mean of chocolate candies in the 3 different kinds of trail mix.
Let me check.
There's a difference in at least one. I think we have to keep that.
Yeah.
In at least one of the mean.
Okay, at least one.
I'm pretty sure that's. Let me find my paper.
No, I don't have it. How we wrote that. So there's sufficient evidence to suggest that there. See, this one has there is a difference.
There is a difference in the means of
mean
one or more of the groups from the others. So,
okay, wait a minute. So
there's a difference in the mean of one or more of the trail mix, the mean of one or more chocolate candies. Wait, one or more trail mixes containing chocolate.
okay.
Does that sound right? There's a difference in the mean of one or more of the trail mixes containing chocolate.
Okay.
I don't know. Does that sound right?
Yeah, that sounds good.
So I have sufficient evidence to suggest that there is a difference in the mean of one or more of the trail mixes containing chocolate.
Yeah.
Okay, so my action, I don't know.
I think that was fine. I don't know.
Like
what does it say to do for take action?
Yeah, I haven't looked into that.
That just said, what did it read? No, I covered it up somewhere. It just said like, it gave some examples, but nothing was close to what we did. So.
Oh, okay.
Oh, here it is. So the take action, it says the goal of a statistical analysis is to determine what actions in a particular situation. Actions can include many things: launching an internet campaign, expressing gratitude or not, getting vaccinated or not. In one or two paragraphs, describe the action you suggest based on the results of your study.
Yeah, so I'm assuming what you said, like if you like chocolate more, you would buy the second brand.
Yeah.
Or you could do additional studies to see if there's more raisins or nuts. I think that's fine. Yeah.
Yeah, and then another study, if the number of chocolate pieces affected the price of the trail mix, you know.
Oh, yeah.
So you think that's good?
Yeah, I do.
Okay.
So, anything else?
And then what do you want us to do? learn for the PowerPoint.
So if you go in your tab that says Final Project at the very bottom, and you just open up those instructions. If you kind of want to make a slide for, so I can do, because it's talking about it's the different slides to do. And since I wrote design the study, I can do that slide. Data collection and describe. Cheryl, do you want to do the 2 and 3 data collection? Because we sent you our graphs.
Okay.
And it doesn't have, I don't think it has to be a lot, because it's on number 6. It says, don't cram your slides with a bunch of stuff. Just kind of like an overview kind of thing. Make it pretty simple, I'm assuming. And then Wendy, if you want to do 4 and 5, if you guys want to, you can just like type it up in a Word document and make sure like I know what information is with what part, and then I can, if you send it to me, I can compile it into a PowerPoint presentation.
Okay.
And then I can send it to you when we're done. I'm done with it. And
like we'll just send a Word document saying like slide number 4 and then the information.
Yeah. And make sure you have like, if you want a title for that slide, make sure you have a title there.
Okay.
Pretty much what I'll do is I'll just pretty much copy what is ever on your Word document and paste it onto a slide.
So do you want to create, can you create a PowerPoint in the Google?
Oh yeah, I can do that.
You can all add to?
Oh yeah. Do you guys want to do that?
Would that be easier that way?
Yeah, I just don't know how to do that, but.
Yeah. Let me see.
It's only 6 slides.
I can create a Google Doc, I think.
When is this final thing due?
Next week? Yeah, the presentation, the PowerPoint, we have to, it's due Thursday.
Okay.
It's due Thursday night.
Okay.
On the 14th, it's due. And then the evaluation is super simple. I just looked at it right before our group meeting, and it's just, it's like a peer review thing. You just like enter in the information, how you feel your group lead, like your group participated and stuff like that. Perfect. So that one's not hard at all. It'll take you like 5 minutes.
Okay.
But yeah, I'll try and figure out how I can make a PowerPoint presentation and share it with you guys, and then
we can add this.
Yeah. Okay. And if anything, if I can't figure it out,
we'll just add our stuff or send our stuff to you.
Yeah, I'll let you know if I can't figure it out. I'll send a text or whatever, and then
okay,
we'll go from there or whatever. Yeah.
Okay.
Anything else?
I don't think so.
No.
So do you want me to send you the things we talked about, and I kind of revised it before I turn it in for the inference? And
I think if you correct it, you can probably turn it in if you want to. I don't know.
Okay.
Because I think we already
went over it.
Yeah. I mean, if you want to, that's fine, but I think you did a great job on that.
Okay. Perfect.
Okay.
All right.
Sounds good.
Okay.
Hey, bye.
Bye.